Everybody poops. People poop. Cats poop. What the? Sir Isaac Newton?
Did you know that we can use physics to describe an apple falling from a tree?
No way!
Yes way! Yes way! I invented the universal law of gravitation, which can describe an apple falling from a tree. When it first falls at a velocity of 0 meters per second, it accelerates down, and that acceleration is due to gravity.
How do I solve for velocity?
Well, you need the time and the change in position. The average time it takes an apple to fall from a tree is 1.8 seconds. The average height of an apple tree is 5 meters. That's about 2.5 men stacked on top of each other. So then, all you need to do is divide your change in position by your change in time.
What was that acceleration thing you were talking about, Newton?
Acceleration is due to gravity. Gravity is what pulls the apple down during free fall. And the value of gravity on Earth is 9.8 meters per second squared.
What else can we solve for?
Well, okay. You could solve for the force. You solve for the force by multiplying mass and acceleration. You already have your acceleration from gravity, which is 9.8 meters per second squared. Then you need your mass. The mass of the average apple is 0.185 kilograms. That's about 5 Hot Wheels cars. So you just multiply that by gravity to get your force.
Does the apple have to do anything on the way down from the branch?
Actually, it does. It's called work.
I thought work was like accountants or something.
Yes, but there is also a way you can solve for work using physics. Let me show you.
You solve for work by multiplying the force and the distance together. The force is 1.813 newtons. That's equal to the weight of 2/10 the can of Pepsi. The height of the average apple tree is 5 meters. So you multiply those together to get your work.
Well, that is just dandy, Mr. Newton. What else can I learn from you today?
Well, my young sapling, we can solve for the power.
Well, good golly, Mr. Newton, how can I solve for the power?
Well,
Have you noticed now?
you know how a microwave has a certain amount of watts? Well, a watt is the unit we measure power with, and you can solve for power by work divided by time. So the work is 9 joules, and that work is about half the weight of a paperclip, and the time is 1.8 seconds. So you divide your work, which is 9 joules, by the 1.8 seconds, and you get 5 joules of power, and that's...
Let me see if I'm getting the hang of this whole apple falling thing. Is there any energy going on with that apple?
Actually, there is. You can solve for potential energy and kinetic energy. Let's start with potential energy.
All right. Here.
Potential energy is the energy that is stored and ready. To solve for potential energy, you multiply mass, gravity, and height. Mass is 0.185 kilograms, gravity is 9.8 meters per second squared, and the height of the apple tree is 5 meters. Multiply those together, and you get 9 joules. That's again about the half weight of a paperclip.
What's the dealio with that kinetic energy, Mr. Newton?
Well, kinetic energy is the work required to bring the object's current velocity to rest. To solve for kinetic energy, you multiply 1/2 the mass, which is 0.185 kilograms, times the velocity squared, which is 7.29 meters per second.
So, Sir Isaac Newton, is there any other types of energy we can solve for?
Yes, the final thing you would solve for is total mechanical energy. You add potential energy, which is 9 joules, with kinetic energy, which is 0.68 joules, and that's about half of a rubber band, and you get 9.74 joules as your total mechanical energy. And that's the end of our lesson.
Thanks, Mr. Newton, for teaching me all your wisdom. Physics is everywhere.
Yes, it is. Now, if you'll excuse me, my people need me.